like wild when you walk in here. You're the only, and this is not your fault, but you're the only class of mine where I'm teaching a certain math class and then immediately have to switch everything to teach a different math class, right? The class before you is not the same class as you. So when you walk in here, I am begging you, just sit down. Do not attack my desk. Do not come ask me a question specific to you. Do not come try to hand me a paper. Like, you have AO and extensions to have private conversations with teachers. This time is class time, and I only get 45 minutes of it a day, and a lot of weeks, some of that gets stolen, especially right now for announcements, right? We keep losing class to announcements. So I really, really, please, that would help me out a ton. For what it's worth, if I, try to pull on your heartstrings a little bit, I have a heart condition, so, stress isn't necessarily the best thing because that increases your blood pressure. So, I try to minimize my stress. I try to be a pretty positive person. And when 6 kids are standing at my desk, like, Mr. Hudson, Mr. Hudson, Mr. Hudson. No. Literally, I'll just tell you, stop, go away. You don't need to ask to go to the bathroom. I'm going to say it again for those in the back. You don't need to ask to go to the bathroom, especially in between classes. Guys, that's your time. Literally, you have 2 minutes in between classes to do whatever. Then you're supposed to be here, but still, we don't have bells. Please do not show up and ask me to go to the bathroom. That's silly. Come on, don't be silly. We are going to start numbering the questions on our notes so that as I walk around, I can tell, okay, you are working on the problem that we're working on, because at least you have that number written down. So we should have out 1, 2, 3, and 1, 2, 4. Guys, that was number 1. If you didn't do that, why'd you move on to number 2? We should have a new graph paper with a header that says rewriting fractions, and it should be folded hot dog style. Just because our problems aren't that big, we don't need to use the entire sheet of the paper. We can go down 1 column. 1, 2, 5 you'll need for the final problem of the lesson. You don't have to get it out now, but you will want it out at some point. You might already have it out because you probably have the packet out. And anyone need the plan book? This is a little bit not as great for you guys because you have me at the end of the day. So if you forgot this, might be kind of like, oh, these are due today. And that includes yesterday's homework. Because tomorrow's a game, right? Tomorrow we're playing Jenga. It's like a reward for having done your homework on time. So it doesn't have to be turned in class. You can turn it in at extensions. So 1, 2, 2 through 1, 2, 4 should be turned in at 8. We're about to check 1, 2, 4. And we can take questions on it. We can do problems together. Especially if you are still working on it and you go to extensions, but you don't necessarily want to come and work with me. Yesterday during extensions, oh, not there. Here. So again, you could search Micah Hudson to find me, right? Yesterday during extensions, I did your homework for you. Couple problems, that is. Problem 94, problem 80, done. Because kids came and asked for help. If you come and ask for help, I'm going to record it, and all your classmates are going to be able to benefit from it, and you're going to be able to watch it again. For those of us that are struggling with area of trapezoid, on the mastery that we have to revise that I gave you guys back yesterday, I made a video specific to area of trapezoid work, and I did it 2 different ways. Right? I did one straight up from your homework, and then I did another one that I just made up because I wanted to do one of another shape, and I solve it 2 different ways. So guys, my YouTube is there to help you, right? I honest to God do not care about how many subscribers I have. I never am going to make money off that, but it's there so that I can quickly get stuff out there for you. Yes. Yes, we're going to go over both of those. So 1, 2, 3, and 1, 2, 4, pull them out. There are other options here. That's why this says a possible response. We went over 80 yesterday, but if you are still confused about problem 80, go watch the video on my YouTube. I talk about it real, in good depth. What? Yeah, which one? Give me just nope. That's con. I don't want that. So this is a proportion problem. So since they give us the amount of yards, we need to figure out how many like loops it was. So the park is 150 by 125, but that's like 150 across, 125 down. So we have to go another 150 and another 125. So really the park together is how many yards in one loop? 500. Wait, 550? Sorry, 550. Okay, so 550 yards makes one lap or one time. If you take your million and divide it by 550, that's how we get to this answer. Yeah. 84B, thank you for asking. Probably a trapezoid, I'm guessing. Oh, thank you. They asked about this morning, too. I should have realized, like, we definitely need to talk about this. This one's real weird because the part of the triangle you see is like, wait, what the heck? Like, it kind of messes with you because you're like, well, I'm looking for the height, but... Oh, yeah, I need to clear this ink. So, guys, if you, like, walk up a hill or walk out like a plank, you know, if you're on a pirate ship or who knows what you do on the weekends, and you are trying to figure out the height of an object, you would not stop right here and say, I'm at the height of the object, because it keeps going up. You also wouldn't stop here and say that that's the height of the object. So what we actually have to do is go all the way up and then drop drop something. Like literally the vertical height that gravity lets us say, how far was that? What's weird is that's not part of the triangle, right? The parts of the triangle are 9, 14, and 7. This 4 is your height, though. We always, and if you go back and look at page 10 and look at the formulas, we're looking for the perpendicular symbol, right angle or perpendicular, can be called both. That symbol indicates this is our height. The base is still just this 9. So our formula there that we need to use would be half of 9 times 4, because base times height. So 9 times 4 is 36. Half of that, sorry, my brain was writing 18 when I meant to be writing half. Yeah, half of that is 18. No naked numbers, meter squared. Yeah. Because it's a triangle, and triangles compared to rectangles, like any triangle, no matter which way I draw it, only takes up half as much space as a rectangle. So the 9 times 4 would be if it was a rectangle, like if I drew this as a rectangle. But the space the triangle takes up is half of it. The 14 doesn't matter. The 14, if I care about the perimeter, then the 14 matters. But when I'm talking about area, I just need the base and the height. And like I said, the height's not actually a piece of the triangle. We just dropped something and said, how tall are you? Yes. Yeah, it's a trapezoid. So, I'm going to tell you the formula, but I'm not going to solve the whole thing because my YouTube video has a review of trapezoids and we got to start our lesson today. For trapezoids, I like, and there are 2 different formulas, which is why I'm saying go look at my YouTube because I do both of them there. I like to add the bases and put it over a 2. The other way to write it is half times base 1 plus base 2 times height. These are the same. So if you see the two different formulas, they're the same mathematically. The trick is, and what gets most kids, and really people, adults can't do this either, the bases are the sides that are parallel to each other. So the tricky thing here is the base is not the bottom. Base doesn't mean bottom. Like that's like, and that feels wrong to say, right? Like base, the base of an object is normally the bottom. But could I like push this thing over and lay it down and make that the bottom? Yeah. Just like if I walk over to this 3D object and lay it down, like the bottom's not the bottom now, right? Like bottom is relative. So the height is the distance between bases. You guys, all of this is on page 10 of your textbook. When we covered it, when we first gave out your textbooks, I advised that you would put a Post-it on it. I'm betting most of us didn't, and that's okay, because I teach middle school, and I know what 12-year-olds are like. I love you guys. That's a compliment. Like, I know you, and I know when somebody says, hey, you could do this thing. You're like, man, do I really want to? Page 10. Right here, guys. Page 10. Area of a trapezoid. So you have a textbook. I just like it better doing B1 plus B2 over 2. They do the multiplication by half. They're the same. They're the same. All right, and then I think we still need to check 1, 2, 4. So here's your 1, 2, 4. At this point, nobody should really be chatting because we're all checking. I'll make it a little bit bigger. I don't think the question actually specifically said that, but if you did it, awesome. Sweet, that's good. That's a good thing. Extra practice is always good. Now, 91 wants decimals also. I'm a fan of improper fractions. So unless there's a specific reason that we need to convert it, or unless they ask you, a lot of times, like if kids come up and they say, can I leave it improper? Yeah. Like 7/5, that's, to me, that's kind of as good as 1 and 2/5. It's quicker to say. Saying 7/5 is faster. All right, questions? If you are writing down answers, quite honestly, I don't really care that much, but if you are writing down answers right now, you better understand how those answers are the answer. If you don't, it's going to be a problem later. It's going to be worse later. All right, the answers are also in the video, so if you need those again later, the morning video is already up with all the answers in it, so we got to keep rolling. So your paper should look kind of like this, with a fold down the middle. At the top should say rewriting fractions. If it doesn't say rewriting fractions, please make that happen. There are those words if you need. Can anyone remind us what we did yesterday? And why, like if you look at your packet, and you look at like this picture right here on the front of your packet at the top, what were we doing and why? Like, so I'll scroll down and maybe this will jog memory. What were we doing with these images and what was it accomplishing? Is that hand still up or no? Shh, we do a volunteer. Okay. So I'm going to repeat because I don't think everyone can hear. She said, yesterday we were converting to percentages. So what did we do to get there?
So we have pictures like that one, and I'll go with our example. 25, we have to find out how much we need to get to 100 because a percentage is out of 100.
So this is 10 out of 25, right? If we're normally talking about what is shaded. So if we want to talk percent, like we just got reminded, I just make it over 100. What did we use yesterday to do that? Did we talk about the name of it? The giant one. So that is what we're going to be doing today as well. But we don't always convert fractions into a base of 100. That's only for getting to percents, right? So here's your first objective. Write down hashtag 96. Because this is problem 96. So I don't have space beside the hashtag, but you and your team, and I'll rewrite these a little bit bigger because I know they're a little bit small, are going to, on B, perform the multiplication they tell you. So we multiply on top and we multiply on bottom. In C, we have to figure out what multiplication to do and then do it to the part that hasn't been done. I will walk around after I rewrite these. So if you have any questions, just ask me then. But you are working with your group. Do the multiplication up here to figure out what it equals now. And guys, if you want an option that doesn't involve drawing the giant one, here's your option I'll give you that doesn't involve drawing the giant one. What we're doing is making equivalent fractions. We just take this little in-between step to multiply by the same thing on top and bottom. Macy, pull your mask up. So if we want to show that without drawing the one, we can just do arrows. This says this is what I'm doing on top and bottom. So instead I could rewrite this with just times 6 on top and times 6 on bottom. Instead of doing the giant one, you can do the arrow method. I don't care, but you can't do neither. You got to show what we're doing. Okay, you have to show what we multiplied by. Yeah, I mean, you can also just write it as times 6 over 6. Like, you don't have to draw the 1 around it. See, I mean, good question. You could also just write it like this without the 1 around it. That's another option. Any questions?
Yes.
I'm coming that way then. Okay, dive into it. What? Oh yeah, no calculator. Thanks for asking, I appreciate it.
No!
Scroll up. There's nothing down there. So here, let's do one together. There's no other question up there. We did that. So, this, the first one on your paper, and as I walk around, I'm going to look to see do we all have, should be the fraction 9/25. Either you can do the arrows, or you can just show it's multiplying by 6 over 6. And if you want, you can draw the giant one around this. Either way, we are finding out what the new fraction is. So, what is 25 times 6? Close. 150. What's 9 times 6? Oh, you guys don't use the finger trick? Put your hands up.
Oh yeah, I know this one.
Put your hands up. Thumbs in the middle. 9 times 6, drop your 6th finger, but I'd have to be standing like this. The answer is 54. 9 times 8, drop your 8th finger. The answer is, wait, no, that's my 9th finger. Sorry, 8th finger, 72. Right? How many fingers on the left? How many fingers on the right? 9 times 5, 45. It's just a funny trick because how the multiples work. Yeah, right. That's the other option. Does this make sense? Do it.
Getting to multiple
Okay, you can only highlight all people after you get math done. Okay, I love that you want to highlight, so you're taking a lot of time on that. You're doing I, double I. Sorry, I did scroll too far now. Yes, it is a 6. So I'll rewrite these now because I know some of us can't see, me included. This is 6/15 times 3/3. Oh, does it take me walking your direction so you can move on to the next one? Well, then tell them. Not tell them the answers, tell them to do work. Yeah, there we go. Do work, right? That's what we're here to do.
And then that's 2 O's.
Aye, aye.
I didn't see the double O.
Aye, aye. Did you know that when Alexander Graham Bell invented the telephone, he proposed answering it with the word ahoy?
Really? Yes.
Yeah, unless the Big Bang Theory lied to me last night, but that's what they said on the Big Bang. So we did I together. Ooh, random cards. Lucy. For I. What do we get in our new fraction, Lucy? 18/45. They talked to me. They're going to deal with a thing. In the next I, Braden, what? Oh, crap, this one's different. Can you talk to me about what the... How do I figure that out? You're not Braden? Oh, crap. Sorry, it took me until I looked around the class. Macy, your card was next, actually. Do you have a question or an answer? Yeah. 8, right? I love how you said that. What makes 40 from 5? Like, how many 5s does it take to make 40? 8. So, what we do on top, we got to do on bottom. Got to be fair, right? Give ice cream to everyone.
No.
All right, fine. Your class doesn't get ice cream. What's 7 times 8? 56. The cake is a lie. Yes. Katie. No. What the heck are you talking about? Then you know more than me. I have math to teach. I'm going to go back to doing that now. So, what? So thank you. Thank you for asking about that. If we are trying to compare, thank you. If we're trying to compare fractions with each other, sometimes we don't care about percents, we don't care about decimals, we just want to compare the fractions, like who got more pizza, right, or who got whatever. So here, what their intention was make the numerator 40. So maybe like we want to be able to cut something into 40 pieces, but what total then, so if it was initially 5 out of 7, another way I could show that is like literally draw, and this is why we've been doing this in our homework, literally draw 5 out of 7. So let's say I order a pizza. Nah, you don't know my pizzeria. I plan on eating 5 slices. I'll leave 2 for somebody else. But then, y'all show up, and you're like, Mr. Hudson, that pizza's way too big for you. And you make me feel self-conscious. So I decide I'll share with you guys.
Excuse me, Phoenix. Could I please have Cooper Florence and Sevi Kissling to the office? Cooper and Sevi. Thank you.
But to share with you guys, I'm going to need more than 7 slices. Hey, Zero, you're about to get a different seat because you're making this harder than it needs to be. So fix it or change your seat. So then I pull out the pizza slicer and I slice 8 slices across. And now I have 56 total slices. And the ones that I had put meat on or whatever that I'd already put red pepper flakes, like what are those now? Well, now those are 40. And there are like 56 total. Let me give you another visual. Here. Same situation. Same situation. 7 pieces. 3 of them, let's say, have hot sauce or red pepper flakes, whatever. You guys come in, you pull on my heartstrings, you say, share with us, we're hungry, so I say, fine. I grab the pizza slicer, and I go to town. I can't get more pizza, right? Like, I only have the 1 pizza. What I can do is get more slices that are smaller. So, I slice, 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 slice. Now, because I did 1, 2, 3, 4, 5 sections, really, that is doing times 5 on the slices that I already put hot sauce on, and times 5 to the total amount of slices. So now I have 15 hot sauce slices out of a total 35. Does that make sense? And I hope enough of you like hot sauce that you're eating that pizza as well. Ooh, no, Frank's. Frank's all the way.
And then I have my dad's uncle's homemade hot sauce.
Let's say we don't know the number 10. And we don't know that this would just be times 10. How could I figure out the number to multiply by? Divide which direction? Divide backwards. So if we did 70 divided by 7, that would get us 10, which tells us that multiplication there is 10. Questions? This becomes 50 out of 70. Y'all are tired, aren't you? This 4-day week has felt long, hasn't it? Oh yeah, you guys did them all. So, this is kind of a dumb question to ask now. I mean, there are no dumb questions. Yes, there are. Yes. Which is bigger? Which is bigger? 3/7 or 15/35? Phoebe? Sorry, Phoebe, say it louder. They're the same. You guys aren't fools. I didn't go buy any more pizza. All I do is slice it up. Quite honestly, some of the pizza probably got left on the pan and the pizza slicer. This is probably actually less, really. But no, they're the same, right? So what we're doing, guys, is we're making equivalent fractions. If you see the fancy word equivalent, it just means equal. Yeah, it looks scary, but it doesn't need to be. So here, and this is kind of a challenge. I want you guys to create at least 3 new equivalent fractions for each of these. So what do I mean? You're going to write down 7/12. Oh, sorry, this is number 98. So hashtag 98. You're going to write down 7/12, and then you're going to write down at least 3 other fractions that are equal to 7/12. So, Eric, you want to give me an idea of something I could do to get a new fraction there? Well, okay. But give me more. Because you can't just say, okay, so times 1. But what 1? What am I going to put in the 1? Anybody? Tell me.
5.
Anything, really?
Just double it. Just double
Yeah,
both
we could
numbers.
do 2. Do times 2 times 2. We could do times 3 times 3. We could do times 4 times 4. As long as it's the same on top and bottom, it doesn't matter what you do. You know anything you want? Anything you want. Well, within reason.
Oh, so not negative numbers?
You can't fly home.
I wish I was flying.
Oh, we are going to random card this, by the way, so you might want to list out some fractions on your paper. And not just like sit there and talk.
For all A, B, and C.
For all A, B, and C, that's why I'm prepping up here. Ooh, now this last one looks a little different. The numbers start kind of big. Chloe, give me an equivalent fraction for 7/12. Yeah, we double both. Angel. I'm still trying to say it right. Sorry. How'd you get it? 3/3. I just wanted to make you tell me the details there. Giant 1 of 3/3. Or you can't just say use giant 1. You got to say what you're doing. Sophia. I don't know. As long as the math is right. How'd you get there? Times. Times 8. So double check times 8 on top, times 8 on bottom. Guys, if you didn't think about this one, it's probably the easiest. Just tack a 0 on both of them. Or what about this one? Is that still equal?
Yeah. I did
What
that.
about this one?
Yeah.
Yeah. So guys, there are an infinite amount of equivalent fractions. If I told you list all of them out, like you're here forever. Sorry, you're trapped. You would die. That's a pretty more like immediately going to we would die. I'd bring you food and water and stuff.
But eventually we die.
CX, give me. Moving on. CX, give me equivalent for 3/10.
6/20.
Yeah, he's taking the easy way to start. Might as well. Why make life harder than it needs to be? Peyton, give me another one for 3/10. Yeah, 9/30. So we triple on top and on bottom. Landon, give me another one. You can do the obvious one. Ooh, that was not obvious to me. What I thought was going to be the obvious is do 30 over 100. Right? So wait. Landon multiplied by 4 on top and bottom. Here's an interesting thing. If I asked you to turn this into a 4, trying to multiply 3 and make it into a 4, sounds hard. But if I come over here, how do I turn 12 into a 4? Divide by 3. So I could divide by 3. Oh. That's not going to be very nice, is it? So sometimes it doesn't quite, like we can't do just like anything. But we can do most things. Now, where I would say this is probably going to fall apart is if I divide by 3. I think this becomes repeating. I can't put a repeating decimal in a fraction. I'm going to say it again because people have asked me today. I can't use a repeating decimal in a fraction. But guys, remember, repeating decimals come from fractions. Like 1/9 is 0.1 repeating. Right? 1/9 is 0.1 repeating. So we would have to use a fraction in a fraction and it would be all messy.
So why can't you?
Well, okay, we can. We just don't know how yet. Right now we can't because we aren't good enough at the conversions. Here's what. So you can't. like I'm telling you, you can't. What I could do here is make the denominator 40 divided by 3. That becomes the complex fraction, which actually becomes
Yeah.
which gets us right back to where we started. That's why we can't do it, because if we follow the math, it just takes us right back to the beginning. It's pointless. Chloe.
I would just like to say there are 3 very easy answers.
Ooh.
9/27 is
Hold on.
Couldn't you do
Give me one.
times 1,000?
Yeah, I want. Can I get? Big numbers kind of scare me. Not gonna lie, big numbers kind of scare me. Can I make these smaller? Make these numbers small.
Excuse me, Phoenix. Can I please have Mallory Poland and Zoe Kellner to the office? Mallory and Zoe. Thank you.
Ava, did you have your hand up? Did you have your hand up? Yeah. Do you want to? Can we make this smaller? 9/27. Can we get smaller?
90 over 270?
Well, that's not smaller. I mean, you're right. I can do that, but that's not smaller. 0?
Wait.
Yeah, it's your card's up. Can we get smaller? Can I get smaller than 9/27s?
Yeah.
Give me more.
You
How?
make it smaller.
What can I multiply by
By point something.
and get smaller? Robert.
You divide it by 3, and if you want to multiply it, just multiply by 0.3.
We, your crazy math teacher, back in week 1 of school, said multiplication and division are the same thing. So all we have to do is multiply by a fraction. It's like Robert said, if you do like divide by 3, well guys, that's the same as multiplying by 1/3. What's a third of 9? 3. What's a third of 27? 9. Can I do that again? Yeah. 1/3.
Could I please have Sydney Allwood to the office as well? Sydney? Thank you.
We want to compare these fractions. But I can't, because their denominators aren't the same. In order to compare fractions, you're going to do it on your own for a second. We need common denominators. Also, before we add or subtract, so we need to make common denominators for these fractions. I think I still have a couple minutes, so don't worry, guys. Yeah, 48. I still got a couple minutes. 5/8, 12/16, and 13/24. Guys, I always advise writing down everything we have before we start. Should I just turn my 8 into a 16? Will that work for all 3 fractions?
But you can turn 8.
You should turn the highest number first.
So wait, what do you want me to do with all the fractions? Make them all
Single denominator.
have what? But what denominator? What number? Should I use 8 or 16 or 24 or something else? We can use 24.
I also need Charlotte Ogdenus to the office.
Guys, what's happening is parents are showing up to get kids, and they call in and they say, hey, page my kid. And then we do. But they don't all do that at the same time. No, wait, can I turn 16 like right into... No, I could, but I don't know how. I'm not feeling very smart today. Oh, 12 and 16 are both what? Robert?
They're both multipliers of 4.
They're both even, and they're both multiples of 4. You're right.
And you just need to keep, because 8 is, or 16 and 24 are both multiples of 8.
So if I make that 8, what's my top? My numerator? 6. And then to become 24, we triple now. So this becomes 18. What's this become over here? What's the numerator for my first one? Anyone? 15. Be ready to see a problem like this in the Mega Jenga review tomorrow. Again, hold on just a second. Again, 222, 223, and 224 are due today. I am going to check those over tonight to see who gets to play the game with us tomorrow. Guys, it's not punishment. If you're behind on work, it's just an opportunity to catch up here. Not punishment. Now or during extensions. Yeah, question. Yeah, but what if we don't have calculators? I said you can't use calculators. Oh. 13 24ths, you're going to do without a calculator? I mean, if you probably can, it's just probably annoying. I think this is like quicker than trying to do long division. Here, I'll put it up on the board. Oh, yeah, 1.2.2, 1.2.3. Sorry, I forgot. We're still in Chapter 1. Thank you, CX, for catching me on that.